In this question I'm going to look at the solution to question 2 from the June 2010 Edexcel M1 paper. The topic of the question is momentum and impulse. The question starts off by telling us that we have particles P of mass m and Q of mass 3m are moving in opposite directions in the same horizontal plane. And they collide. Immediately before the collision, P has a speed of 4u and Q has a speed of ku, where k is some constant. After the collision, the direction of the motion of both particles is reversed and the speed of each particle is halved. So with that information, we're asked to find the value of k, and then after we've done that, to find in terms of m and u the magnitude of the impulse exerted on P by Q. Well, let's put the information that we've got in the question onto a diagram then. We have momentum in opposite directions here for the two objects, and then afterwards we are told that the directions have reversed, like so. So now putting some numbers onto that, this is P with mass m, Q with mass 3m. We're told that the speed is 4u and ku, and that afterwards those speeds are halved. So that means that this one must be 2u and ku over 2, and that the directions have changed. So there's a diagram putting all of the information that we have in the question onto it. So this is a conservation of linear momentum then. So conservation of linear momentum. So if we look at the momentum before the impact, then we have mass m multiplied by the velocity 4u, and then 3m multiplied by velocity of minus ku. So that's before the impact, so that the velocity there is in the opposite direction. After the impact, then we have the mass, which is m, now moving with a velocity of minus 2u because its direction has changed, and 3m multiplied by a velocity of ku divided by 2. So you can see from that that the m's all cancel out, as does u. So all of this will cancel throughout the equation. And if we simplify that, on the left hand side we've got 4 minus 3k is equal to, on the right hand side, minus 2 plus 3 over 2k. Different ways of solving that obviously, but one way is to multiply throughout by 2 to give 8 minus 6k is equal to minus 4 plus 3k. And that gives you a total of 9k equal to 12, or k is equal to 4 over 3. The marking for that part of the question was an M mark and an A mark for correctly getting the conservation of momentum equation, and then M mark and A mark, but it's a correct answer only mark, so you have to make no mistakes to get that final A mark. In part B of the question, we're asked to look at the impulse that we have on P from Q, so that the impulse is equal to the change in momentum. So the impulse then is the final momentum, which is minus 2u multiplied by m, minus the initial momentum, which is 4u multiplied by m. And that gives a total of minus 6mu. Now that's the impulse on P from Q, so the magnitude of that of the impulse is just equal to 6mu. 3 marks in this part of the question. M1A for the momentum equation and then coming down to the minus 6mu, or indeed you could do it as 6mu, and therefore a final A mark. Of 6mu for the magnitude. Well, that concludes the solution to that question. Solutions to further questions can be found at www.furthermaths.org.uk.